So I posted a video on Moodle, which is this one, right? If you go to the Moodle and go down here, final exam review, this includes chapter 4 and 7. So if you click here, you see if you click on that final exam review, click on this to open the resource. So if you click here, you will see a YouTube video, right? I should not have started recording yet, but look at this one. So here, this includes chapter 7. See, this is from the previous semester, but it contains same thing. You see, 4.7, chapter 4.7. As I wrote in the section that this 4.7 is not included for us. I could not do 4.7. So you can just go through 4.346, 7.123. Okay. So this 4.7 is not included for us. So then we have a question from chapter 7, total 2 questions. So it's very similar to what is given here. Right. So you can skip this part. 4.7, you can skip this. So
Victor.
So I will go to the previous one. So this half of the review is there. So if I go to
Victor.
Yes.
4.7 not include to exam.
This is what I'm saying now.
Okay.
You understand Farsi?
Yes.
You understand Farsi?
Yes, Mr. Yes.
Only Arabic? Urdu, Hindi, Farsi, English? So as I told you that one question from simple order, linear, non-linear, etc. These things which we had, in the beginning of the course, that order is the order of the highest derivative. For example, if there is y double prime, then this order is 2, right? Then the order is 2. If you have y triple prime, order is 3, right? This third derivative tells you that the order of the equation is 3. And then linear, non-linear, if all your if you have y prime, y double prime, all the derivatives, if they have power 1 only, if they do not have more than power 1, and no product terms of this y double prime, okay? So then it is linear. Otherwise, it's non-linear, right? For example, if you have x square y double prime minus sine x y prime, right? Then plus 7y. These are all linear terms, no issues, because these coefficients have only x in it. So this is linear terms, no issues. But if you multiply y and the derivative of y, or you have y square, or you have e to the power y, etc., these type of things, then it is non-linear. Okay, so you should know if an equation is given, if I ask you what is the order of this equation and whether it's linear or non-linear, you can answer like this. So this question will be a short answer question, one-liner answers. Okay. Similarly, in higher order equations, right? If the right hand side is equal to 0, then we call it homogeneous equation. Okay, homogeneous equation. Otherwise non-homogeneous. For example, if you have x square y double prime minus 3xy prime plus y is equal to cosine x. So see, the right hand side is not 0 here. Then it means equation is non-homogeneous. Okay. If you have the same thing, equal to 0, then it is homogeneous. If it is not 0, it's not homogeneous. Okay, so these are just these simple definitions about linear, nonlinear, homogeneous, non-homogeneous, and the order. You don't have to solve anything here. From chapter 4, we have only 4.3, 4.4, 4.6, right? I did not do 4. So leave the part, of the video which I uploaded, right, on about 4.7. So if there is 4.7, just leave that part. No need to consider this. Okay. So I will give you one question from here. This is homogeneous equations, and one question from here, which is non-homogeneous equation. There are two methods to solve a non-homogeneous equation. I will just give you a non-homogeneous equation. It's your choice. You want to use 4.4. Choice is yours. If you use 4.4 or 4.6 to solve this question. Okay. So from here, if you want to solve this question, it's your choice now. I'm not giving you both the questions. Okay, I will write one non-homogeneous question, and it's your choice. You want to use 4.4 and 4.6. One question from here will be given about homogeneous equation. You know that the homogeneous equation is very easy. We have constant coefficients. Let's say y double prime minus y prime minus 6y equal to 0. Let's say this is the case. This is a homogeneous equation because the right hand side is 0. That's why homogeneous. It's a constant coefficient. You see the coefficients are constant here, 1, minus 1, 6, constant coefficients. And it's a second order linear homogeneous equation. So to solve this, we write, the first step is we write auxiliary equation, right? So this is your step 1. We write auxiliary equation. In that video, I have done that as well. So you can watch that video as well. What is auxiliary equation? We replace y square by y double prime by m square minus y prime by m minus 6y with nothing. Okay. So y double prime is replaced by m square. Y prime is replaced by m, and y is replaced by 1. No m here. Okay. Remember that. So you see minus 6 into 1. Now I will find its factors. M plus 2, m minus 3. M plus 2, m minus 3 are the factors. So you got m is equal to minus 2 and m is equal to 3. So as you see, there are two values of m which are not the same. So these are two distinct values, distinct real roots. Roots are real and distinct. If this is the case, then the general solution is, this is the step 2. After solving that, step 2 is write the general solution. Then the general solution is y is equal to c1 e to the power m1x. Okay, whatever the first value is, it will go to e to the power minus 2x plus c2 e to the power 3x. So see here, this minus 2 goes to minus 2x, and this 3 goes to this 3x. Okay, so if you have distinct real roots, then how you write to solution? Okay, c1 e to the power first m value into x, c2 e to the power second m value into x. It's very easy. If you have we have repeated real roots, not distinct, let's say if you solve an equation, auxiliary equation, and you got m is equal to, let's say 2 and m is equal to 2. You see, they are both the same. then your general solution will not be this. Then the general solution is y is equal to c1 e to the power 2x, c2 e to the power 2x. But you see, they are both the same. They are both the same, so I cannot have the same form two times. So when the root is repeated, we multiply the second one by x. So this extra x goes for repeated roots, okay? For repeated root. So first time I will write it as it is, e to the power 2x. Second times x e to the power 2x if the roots are the same. And the third case was if you have complex roots, let's say. If you solve the equation and you got complex roots. Complex roots are of this form. M is equal to a plus minus iota b, right? Then you write your general solution as this a goes to x power ax, a plus minus iota b. So see, I wrote a here with exponential, but that iota goes c1 cos bx plus c2 sine bx. We don't write any iota in the solution. Okay. So if you have this a plus iota b, then this b goes to sine and cosine. B goes to sine cosine, a goes to the power. For example, if I have an equation y double prime 4.3, let's say here, I think this will have 16 minus 25. Yeah, y double prime minus 4 plus 5. Let's say this. So if I write the auxiliary equation, I will write m square minus 4m plus 5 equal to 0. I think this has roots. No. So there are no factors. So you can write the quadratic formula 16 minus 20 divided by 2. B square minus 4ac. So now you see 4 plus minus square root of minus 4. So when you have minus 4 in the square root, it becomes iota. Plus minus 2 iota divided by 2. So if you divide by 2, it will become 2 plus minus 1 iota. So now you see your a is 1, a is 2 here. This is a and b is 1. It's not written, so it means your b is 1 here. Okay, it's not written, so b is 1. A is 2, b is 1. So you can write the general solution. Therefore, the general solution is y is equal to e to the power ax c1 cos bx plus c2 sine bx. B is 1, that's why I'm not writing 1x is x, right? So I'm not writing 1 here. So that's how you can write the general solution if you have complex roots. So one question will be like that, okay? One question, I will ask you maybe 3 parts. In this question, I may ask you 3 parts, one with distinct real roots, one with repeated real roots, one with complex roots. So you should know how to write the solutions. Quickly, see, it takes just 1 minute to solve the characteristic equation and 1 minute to solve the solution, maybe. 2-3 minute answer is there for this question. Then I will, from 4.4 and 4.6, I said I will give you a question with non-homogeneous, right? And that is also in that. So I will not give you 2 questions. I will just give you 1 question. It's your choice which one you want to use. Either you can use this or this. There are 2 methods. One method is method of undetermined coefficients, method of UC, undetermined coefficients, and one is variation of parameters. Variation of parameters, and that is 4 point. So variation of parameter has a difficult formulas. I will write this formula in this. This formula will be given. Formula given in exam. Okay. For 4.6, I will write the formula of method of variation of parameter. So when non-homogeneous equation is given, you have something on the left, let's say, right, anything, and on the right side you are given something. Okay, then some function is given on the right side, so it means it is a non-homogeneous equation, right? So its solution is not, its general solution is not just y. It has two things in it, yc plus yp. So yc comes from the same, the solution of yc is the solution of homogeneous problem. Means you forget about the right hand side, just write the auxiliary equation, right hand side is 0, and find the solution like in 4.3. So the solution that you get here, if there is something written on the right hand side, then this is just yc, it is not general solution. Okay, so if the right hand side is there, I will write the auxiliary equation with 0 on the right, and I will write the solution which is just half of my solution. Okay, so if then yp, this yp is the solution from section 4.4 and 4.6. So 4.4, 4.6 methods are given to find yp. Okay, so if you go to that video, right, I told you in detail. Um, you see here, I am doing one problem with 4.6. I did one problem with 4.4. So you can repeat this. See here. So 4.4 will be, this is 4.6 number 24. So you can see this one, 4.6 number 24. I think it's 20 minute 22. From 22, yeah, that's it. From 22 to 20, 30. Yeah. So I did this 4.4 as well. 22 to 32. So you can watch the review video from 22 to 32 almost. Okay, for 4.6. And then you can watch it from 33 onwards for 4.4. So let me show you where. So instead of doing it again, it's 11:30 almost. So I think it's better if I just do the method of undetermined coefficients. So I think that completes 4.3. Yeah. So that comes 32 from 41:36. Right. So instead of just going through it here, you can watch that video and complete it. Here, Laplace transform, and I'm asking you just to use tables like this. Okay, use tables to find the Laplace transform. So you can use it from 50, 30 to 50, 30 to the end for Laplace. And two questions from chapter 7. So again, watch video from 50 minutes 30 seconds up to the end. So let me just tell you what we have in chapter 7. We have 7.1, 7.2, and just a simple property from 7.3. In 7.1, 7.2, we have Laplace transform and inverse Laplace transform. We call it LT, and then inverse Laplace transform. So you have to find one question will be given just using tables. One question will be tables will be given in the exam. So using tables, right? Tables will be given in exam. Find Laplace transform of some function. I will give you a function. You will find the appropriate formula, and to find inverse Laplace transform, right? Like Laplace inverse of some function of S. Okay, so if you look at the table, for example, if I ask you what is the Laplace transform of e to the power 3t. So in the table, a formula will be written e to the power at, which is 1 over s minus a, right? This formula will be given. So from here, you can see that my a is 3. Here a is coming here. So it means I will write this as 1 over s minus 3. That's it, right? So this 3 will come down here. So if it is e to the power 3t, this is 1 over s minus 3. Because if this was a, then this was a here. Or there is another formula, Laplace transform of t to the power n. This will be written as 1 over Sn plus 1 and n factorial as well, right? So if I ask you to find the Laplace transform of t to the power 3, let's say, then it will become 3 factorial divided by s to the power 3 plus 1. You see, when there is n gives you n factorial over Sn plus 1. So 3 factorial is 6 and S3 plus 1 is S4. That's your answer. Okay. So similarly, you can find the inverse Laplace transforms as well. That if I ask you the opposite, that what is the inverse Laplace transform of 6 over S4, or let's say just 1 over S4, if I ask you this. But you know that the Laplace inverse formula needs n factorial in it. If you have 3 factorial over S4, then I know what is the Laplace transform. So it means I can divide this 3 factorial outside because I multiplied this thing here by myself. So I should divide it outside to balance it. Okay. Now I know that Laplace transform of this thing is t to the power 3. You see? T to the power 3 is Laplace inverse. So my answer is 1 over 3 factorial t to the power 3. So it is 3 t6 t to the power 3 by 6. That's my answer. All right. So these type of things you can expect. It is done in detail in this video. Right. I have done this in detail. You should watch this 20-30 minutes of the video. 40 minutes of the video almost, right? And one question will be from solving differential equations, solving initial value problem by using Laplace transform. Okay, this is important. So one question, finding Laplace inverse Laplace transform. One question from there, right? That's why I wrote two questions from chapter 7 and one solving. What is in solving if a differential equation is given along with the initial condition? IVP means an ODE plus initial conditions, two things. Okay, so if your equation is given, let's say here, if I pick something, let's say y prime plus 6y is equal to E40. And then initial condition is also given, y0 equal to 2. So what is step 1 is that take Laplace transform on both sides. Both sides take Laplace transform. So Laplace transform of y prime plus 6 Laplace transform of y is equal to Laplace transform of E40. Now from the tables of Laplace transform, you know that this is 1 over s minus 4. This is 6 Laplace transform of y, and Laplace transform of the derivative is s Laplace of y minus y0. This also comes from the table. Okay, so from the table, it will be given what is the Laplace transform of y prime? It is s Laplace of y minus y0. Laplace transform of y double prime, if you need that, it will be s square Laplace of y minus s y0 minus y prime 0. Okay, so you can put the value. See, y0 is 2, so I can put it here. This is equal to 2, right? So I can put this value directly here. I can put this value directly here, which is 2, right? So this is equal to 2. So my condition is already used. So now you see s Laplace of y, 6 Laplace of y. I can write them together. S plus 6 Laplace of y. And this is plus 2 equal to 1 over s minus 4. Now you can send this 2 over there, minus 2. So this will become 1 minus s plus 8 over s minus 4, right? Minus 2s. 1 minus 2s and 4 to the 8. And here I got s plus 6 Laplace of y. So this is your step 2. Once you take Laplace transform, your step 2 says that solve for y. Means bring Ly on the left, bring Ly on the left, and write every other thing on the right. So this is 8 plus 1 is 9 minus 2s over s minus 4. So this is minus. This is minus, right? Minus. So this is minus 2 and it will become plus 2 here. So this will become 1 plus 2s minus 8. So this become 2s minus 7. 2s minus 7. And now if I divide this s plus 6 here, I got s plus 4, s minus 6. Okay. This is the step 2. And then step 3 is because I want y. I don't want Laplace of y. I want y. So y becomes Laplace inverse of 2s minus 7 over s minus 4, s minus 6, s plus 6. Okay, so this is inverse Laplace transform. Last step is take the inverse Laplace transform. So you got this one. Now this is a question from 7.2 that how to find the Laplace inverse transform. Okay, so I think this is there in the See, this question is done over there. 34y prime plus 6y is equal to e to the power 40, y0 is equal to 2, right? So you can see I have completed this problem here. Okay, so you can watch how to find Laplace transform. Okay, so it is at 55, 56, right? So this is done in review video. Watch from 55, 55, 53, almost 56, 55, 30. You can see that. Okay, so if you watch from this time, right, the video, you will get the final answer. Okay, so you will get the answer, and you don't need to use this condition to find the value of c, because this condition is already used here. So now no need of this condition, and you will not get any c in your answer. Okay, your final answer will be just a function without any c. Okay, so this is a very easy method. All you need is just remember these 3 steps to solve a differential equation using Laplace transform. So these all tables, formulas, these are given uh, in your exam. At the last page of the exam, all these formulas will be written over there. So one question that I did not do in the review session because it was not included for the previous semester. And if you look at that, I wrote that here. You see, if you go to this final exam review, I said, in your final exam, there will be a question from section 2.4, exact equation. This is something which I never asked, not in midterm, not in quizzes. I left it for final exam because they said there should be some part from the midterm as well. So this is the contribution from the midterm. So there will be one question from exact equation. So let me do that because I did not do that in the review session. Exact equation, section 2.4. So there will be one equation like that. So this equation is a function of x, y will be given with dx plus a function of x, y will be given with dy equal to 0. This. And now they wake up because we have exam tomorrow. Whole semester keep sleeping. Okay. So we take the derivative of m with respect to y. You see, m is with x, but we take the derivative of m with respect to y, and derivative of n with respect to opposite x. And if they are equal, right, then the given equation is exact equation. Is exact. Okay, so this is the first thing you have to do. First, find the derivative. If it is exact, right, then the step 2 is then we find a function fxy such that the derivative of f with respect to x is m and derivative of f with respect to y is n. These m and n. Okay. And then we integrate these two functions. We integrate this with respect to x, right? Integrate with respect to x. It will give me fxy equal to something and plus constant of integration, which is gy. And we integrate this with respect to y because these are partial derivatives. So when you take the partial integral, it will give you a constant of integration as the function of other variables. So see, when we integrate with respect to x, it gives me gy. When we integrate with respect to y, it gives me gx. Then we compare these two. Because it's the same function on the left. So by comparing these two equations, we find Gy and Hx, right? These Gy and Hx. Once they are found, my f is completed. Therefore, my fx is completely determined. This is f, but I'm looking for the solution. I have to solve this exact differential equation, right? So if I have to solve it, then I have to write the solution at the end. Solution is very simple. Then the solution of exact equation is fxy equal to constant. The function which you found from here, just put it equal to constant. That is your solution. Okay. So let me show you an example, similar to what will be coming in your exam. So these are the questions. So for example, if I do a simple one, second degree equation. Right? So here you can see that thing with dx is m and the thing with dy is n, right? So here my m is 2xy and n is x square minus 1. Now I will take the derivative of m with respect to y. For y, 2x is constant and derivative of y is 1. So it is 2x. And similarly, n with x is 2x minus 0. So that is 2x. So see, both are equal. Partial m by y and n by x are equal. So it means that the equation 1, given equation, is an exact equation. Now, if it is an exact equation, step 2 is find a function fxy such that partial f by partial x is m, m is 2xy, and partial f by partial y is n, n is x square minus. Okay, so I will integrate this first equation with respect to x, right? Because the derivative is x here. So if I integrate, I will get f is equal to the integral of with respect to x, integral with respect to x. So 2 and y are constant. So x will become x squared by 2 plus a function of y. And if I integrate the second equation with respect to y, right? If I do with respect to y, I will again get f on the left. And with respect to y, x square is constant. So I will get y with it. And then 1 is constant. Y also becomes y with it and plus a function of h. Now you see, if I call it 2 and 3, right? And if I compare 2 and 3, compare 2 and 3 gives me, you see here, I have the same thing. Yeah, this 2 and 2 cancels. So you see the first term is the same as first term, no difference. This is only a function of y. So it means gy should be this. Gy should be this. And there is no function with hx, so it means hx should be 0. Because if there is any x term, I will call it hx, but there is no hx, right? So I can say that if I compare, my gy should be equal to minus y and hx should be equal to 0. Now they both will give me the same function. Then both 2 and 3 gives me fxy equal to, the both give, you see, if I put gy equal to minus y, it will become x square y minus y. Or if I put hx equal to 0, I will get x square y minus y. So both equation gives me the same function, right? So once we are done, once we got the function, then function is equal to constant is the solution. Okay, hence the solution of equation 1, which is my given exact equation, is fxy equal to constant. So what is my fxy? It is x square y minus y is equal to constant. So that is my solution. If you can find y from here, it's good. If not, then don't worry. Okay, solve for y if possible. Solve for y if possible. So see here, if I take y common, it will become x square minus 1 is equal to c. So I can divide x square minus 1 over there. So it becomes c divided by x minus. If it is not possible, you can leave it here as well. This is also a correct solution, no problem. Okay, if it is not possible to solve. If it is possible, it's good to write like that. All right, so this will be your last question. So here, if you want, you can try some questions. You can look at this example, or I did this example. You can see example 2, or just do a simple question from here. Maybe question number 1, right? Or you can do maybe 5. 5 is second order, so it's good that you do the second order, third degree. Okay, so this one is maybe good. You see the derivative of this with respect to y is 3y square. Derivative of this with respect to x is also 3y square. So they both are equal. It's an exact equation. You can solve that. So try any one like that, just a polynomial one. Don't go with sine, cosine, or log x. Don't worry about that, okay? So I think they will give you enough practice. Do either one of that. Try exercise 5 or 10 on page 70. All right, so I think that's it. I almost told you everything about the exam now, what type of questions you can expect, right? One from simple, order, degree, linear, nonlinear like this. Second, exact equation. Third, homogeneous higher order equation, which I did here, homogeneous part. Fourth is non-homogeneous equation. You can use any method to solve it. Fifth is fifth and sixth, 2 questions from chapter 7, which I said. Okay. All right, guys, I think this will help you. Try to watch that video. Okay, that video will definitely help you. So do not only rely on this video. Watch this video and the other video as well, so that you get the maximum coverage. So I will save this and upload to Moodle along with the video. If you have any questions, you can ask. Otherwise, I can stop the recording and leave.